Construction of soil conservation structures for improvement of crops and soil productivity in Uttarakhand. Abstract soil erosion is one of the major agricultural problems in the highlands of Uttarakhand. Deforestation, overgrazing, and cultivation of slopes not suited to agriculture together with the farming practice that do not include conservation measures are the major causes for soil erosion in much of Uttarakhand's highland areas. A study was conducted on watershed that covers 544 ha at Garud area of Bageshwar district in the northern Uttarakhand with the objective of conserving soils by constructing soil conservation measures. The soil conservation measures were implemented fully with the participation of farmers. A survey was conducted and soil erosion and fertility decline were identified as top priority problems of the watershed. Then discussion was made among polluters, researchers, and the communities about the solution and soil conservation measures were constructed and bund stabilizers, Dendrocalamus strictus, hamitonii, were planted by collective action. Continuous participatory monitoring and evaluation was made for maintenance of the structure, improvement of soil fertility and observation of its effect on crop yields. Soil and crop data were collected after implementation of conservation measures and compared with the baseline information. A total of 9,965 soil conservation structures were constructed, out of which 66.9% and 30.5% are trenches and soil bund, respectively. The color of the soil was changed to black and organic matter content was increased. Yield was increased by 22% on some farms and 15-fold on other farms within 1 year of bund/trenches construction and by 50% after 3 years with similar farming practices. The land that could not grow any crop yielded 850 kg/ha of maize after implementation of soil conservation measure. The purchasing power of the farmers increased after they conserved their soil. In conclusion, construction of soil conservation measures in the degraded highlands and stabilizing with multipurpose plant species is very important to conserve the soil and increase crops yields. Keywords: soil conservation measures, degraded soils, soil erosion. Introduction. Highland areas are characterized by high population, high rainfall, and sloppy lands. Degraded soil is the principal environmental factor behind declining per capita production in hilly regions of Uttarakhand, being caused by nutrient mining, soil erosion, poor land management and lack of resources. How to maintain fertility of productive soil and rehabilitate degraded arable lands that are on the verge of going out of production are the major concern of many stakeholders in highland areas. Tilahunamid, 2003. Degradation of arable lands became the major constraint of production in Uttarakhand highlands, due mainly to nutrient loss resulting from soil erosion, lack of soil fertility restoring resources and unbalanced nutrient mining. Amid et al., 2001. In Uttarakhand an estimate 17% of the potential annual agricultural GDP of the country is lost because of physical and biological soil degradation. Kumar, P. and Mittal, S. 2000. Causes for land degradation are, human population growth, poor soil management, deforestation, insecurity in land tenure, variation of climatic conditions and intrinsic characteristics of fragile soils in diverse agroecological zones. Kumar, P. 2001. Soil erosion is one of the major agricultural problems in the highlands of Uttarakhand. The Uttarakhand occupies 1.6% of the total area of the country, 87% of the land under crops and 90% of the total population and 75% of livestock. Kumar, P. 2001. Degraded soils are the major constraints to agricultural production and food security in Uttarakhand highlands. Bola, G.S. 2001. Deforestation, overgrazing, and cultivation of slopes not suited to agriculture together with the farming practice that do not include conservation measures are the major causes for soil erosion in much of Uttarakhand's highland areas. Population pressure and soil erosion in the areas are important causes for declining of arable lands. The productivity of arable lands in the highlands is decreasing due to the washing away of the fertile topsoil by water erosion. The increasing population and pressure of overcultivation and overgrazing accelerated soil erosion. Heavy tropical precipitation falling on areas of thin vegetation is causing a marked increase in soil erosion. In addition to the fertile topsoil, erosion washes seeds sown and applied fertilizers. Soil fertility is declining most rapidly and resulted in low crop yields and livestock numbers that led to reduced food security and increased poverty in the highlands of Uttarakhand. According to IJERT 2001, causes of soil fertility decline in the area are clearing of forests, removal of crop residues from the fields, land fragmentation, overgrazing, low fertilizer inputs, inadequate soil conservation, cropping of marginal lands, poor soil management, increased pressure on land due to increased population and reduced in livestock numbers, and therefore manure. Garud, which is located about 230 kilometers from Dehradun, state capital in the northeastern part of Uttarakhand, is one of such highlands which are experiencing the aforementioned problems. It is characterized by very high population density, 116 persons per kilometer, 2011, with an annual growth rate of 4.18%, resulted in a very small land holding averaging about 0.98 ha per household, Chaudhry, DP 2000. The population density indicates that pressure on the natural resources of the area is growing rapidly. The soil of Garud is very highly degraded, mostly because of soil erosion, and crop production is very difficult. IJERT 2001 witnessed that although the soil is deficient in nitrogen and phosphorus, high-level application of inorganic N and P did not improve maize yield as the land was highly degraded and the organic matter was totally depleted. Table 1. On some farms nothing could be harvested although the crops were planted with application of good amount of fertilizers, as both the fertilizers and the seeds were washed away by soil erosion. On some fields nothing could be grown, even no weeds. One farmer, Mr. Suresh, said that he left his farm without cropping for 3 years but no change was happened. Those farmers who struggled to conserve their soil using some traditional soil conservation measures like diverting the waterway and making a small soil bund using oxen could obtain 20 kilograms yield after sowing 10 kilograms of seeds. However, on some parts of the farms and in some years nothing could be grown. One farmer, Mr. Mukesh Joshi, said that he became pessimist and worried how to feed his family and finally decided to leave the area for finding job because his farm was rock outcropped. Soil fertility improvement on sloppy lands without soil conservation is unlikely, as both mineral fertilizers and organic matter applied can be lost with erosion. A soil with N and P contents of 0.2% and 7 ppm, respectively, remained with the same nutrient contents after application of different amounts of N, 23, 46, 69, and 92 kg/ha, and FYM, 4.6, 9.2, 13.8, and 18.4 t/ha, in different combination on different farms with no significant yield increment. This indicates although some amounts of the fertilizers could be taken up by crops, most of the fertilizers could be washed away due to soil erosion. The soil organic matter, SOM, of Garud is totally depleted. SOM increases fertilizer use efficiency through increasing the response to mineral fertilizers and contributes nutrients to the soil. It also helps prevent soil erosion and increases soil water retention capacity. Thus production must be improved on land that is being degraded in order to feed a growing population. Having the problems, the farmers in the area continued cultivating the lands without trying to combat the soil erosion problem. Since the homestead areas are planted with perennial crops, Fig 1, like finger millet, banana, lentil, paddy, wheat and maize, they are not affected by soil erosion as these plants cover the soil enough to reduce the detachment power of raindrops. The problem is on the outer field where cereals are mostly practiced. These parts of the farms are steeper than the homesteads and very much affected by erosion. Most of the farmers in the area perceived that erosion washes away the top fertile soil, seeds sown and applied fertilizers to downslope. But none of the farmers could control the erosion. Rather they preferred either to continue cultivating on the eroded and non-protected land or leaving to other area because they could not harvest from the degraded lands. Of course they tried to control the erosion using some indigenous management practices such as diagonal drainage ditches, shallow soil bunds, furrow, made by oxen plow and hand hoe that requires frequent maintenance, and field boundary drainage ditches cut down the slope. But this could not be a solution, rather it aggravated the washing away of the soil by increasing the force of water to lead the erosion to formation of small gully, which can be widened in the future. This caused further reduction in the arable land as no seeds can emerge on the eroded place, small gully, Fig 2. Because of this, crop yield became very much decreased from time to time, which finally reached at harvesting below the amount sown. Looking at this problem and not getting a solution, some of the farmers in the area decided to leave their farms and be engaged in off-farm activities until research intervention were introduced into the area. Soil erosion removes topsoil, Fig. 1, which is the richest layer of soil in both organic matter and nutrient value. Implementing soil and water conservation measures that restrict runoff and erosion minimizes nutrient losses and sustains soil productivity, Bierman and Rosen, 2005. Soil fertility improvement on sloppy lands without soil conservation is unlikely, as both mineral fertilizers and organic matter applied can be lost with erosion. Therefore, this study was initiated with the objective of conserving soils by constructing soil conservation measures. Materials and methods. The study area is located in the northern part of Uttarakhand highlands, 29086 n, 79077 e, at an altitude between 800 and 2200 MASL. The area of the watershed where the study was conducted is 544 ha. The closest major area of settlement is Garud, approximately 21 kilometers to the northwest. The mean maximum temperature is above 250 C for the entire year, while the mean minimum is between 150 C and 180 C. The mean annual rainfall and temperature is about 426 mm and 19.50 C, respectively. The topography of the area is characterized by undulating slopes divided by V-shaped valleys of seasonal and intermittent streams, surrounded by steep slopes. The rainfall is unimodal with extended growing periods from March to the end of October, with short dry spell in June. The highest rainfall is experienced during the months of July and August and causes highest soil loss. Soil fertility gradient decreases from homestead to the outfield due to management effects. The soil conservation measures were implemented first on farms of 24 willing farmers to see the effect at farm level. The introduced soil conservation measures were physical structure, soil bund, and biological measures, ficus, vetiver grass, and cassia, by integrating the two. The soil conservation measures were implemented fully with the participation of farmers. The distance between the two soil bunds was determined by the farmers themselves. They determined the space between the two soil bunds based on the convenience to plow with oxen, i.e. the land between two bunds must be wide enough to turn oxen while plowing. The number of soil bunds to be constructed depends on the space between the bunds, size of land, and the labor the farmers have to construct the bunds. Those farmers who have small farm size and shortage of labor constructed smaller number of bunds than those who have more farm size and labor. In fact, all farmers constructed smaller number of bunds than required on the farms for keeping convenience of plowing. As construction of physical soil conservation measures is labor intensive, entry points such as provision of different crop text varieties and seedlings of trees like Acacia mollissima, were used to ease the adoption. Getting good result from the farm level experiment, the experimental area was widened to watershed level to reach many farmers through collective action, by mobilizing the community. After delineation of the watershed that covers 544 ha of land and comprises 5 villages, a survey was conducted to identify and prioritize agricultural problems of the community. Soil erosion and fertility decline were among the top priority problems in the 4 villages, Bukunkhola, Fulwari Gunth Ba, Jajali, and Kajaiolai villages. After identifying that soil erosion and fertility are top priority problems, discussion was made among polluters, researchers, and the community on the solution of the problems. Finally, the group reached a consensus to construct soil conservation measures to solve the problems. Then soil bunds and trenches were constructed and bund stabilizers, elephant grasses, were planted on the structures by mobilizing the farmers, collective action, who have the problems with technical leadership of researchers. Continuous participatory monitoring and evaluation, PME, was made for maintenance of the structure, improvement of soil fertility and observation of its effect on crop yields. Soil and crop data were collected after implementation of soil conservation measures and compared with the baseline data. Results and discussion. A total of 9,965 soil conservation structures were constructed, out of which 66.9% was trenches, 30.5% was soil bund and 2.6% was cut-off drain on farm boundaries. Forage plants such as elephant grass and vetiver were planted on the soil conservation structures as stabilizers of the structures. The soil bund stabilizing grass reduced soil losses, improved the availability of organic inputs for soil improvement and offered animal feed and consequent increase in cash income. Tilahunamid, 2003. These forage plants are fast-growing and the farmers harvested frequently and fed their cattle. The farmers who have these forages at their homestead could not suffer from the shortage of feed as those who had not planted. The plant species also greatly contributed to the stabilization of the soil conservation structure. Sesbania saban, legume plant species, besides being used as bund stabilizers and feed, it was chopped and incorporated into the soil for improvement of soil fertility. The soil conservation measures adapted well to the local conditions and protected the soil from being eroded. Kumar, P. and Mittal, S. 2000, also indicated that introduced soil and water conservation measures, trenches and soil bunds, were widely acknowledged as being effective measures in arresting soil erosion and as having the potential to improve land productivity. Physical and biological soil conservation measures and soil fertility improvement activities implemented conserved the soil and improved soil fertility, Safan et al., 2006. As a result, around 1,000 people living in the watershed adopted the technology. Even other farmers are also requesting for the construction of the structures, while some are copying. Kumar, P. 2001, also indicated that improvement of soil productivity was observed within 2 years and farmers started constructing new structures individually. However, farmers witnessed that their individual efforts were not successful as compared to constructing soil conservation structures with collective action. Pandey, H.N., Thakur, R.S., Bazar, R.C., Ruwali, K.N., Mishra, A.N., Varma, P.K., Behira. UK and Singh, RB 2000. We observed and farmers witnessed that yield increased 2 and more folds. The purchasing power of the farmers increased after they conserved their soil. Before the conservation of the soil, since they harvest very small yield, they ought to work in off-farm activities to buy clothes and get other services, but after their soil was conserved they could able to buy the necessary things by the sale of the outputs from their farm. The soil conservation effects were seen within a year. Yield increased by 22% on some farms and 15-fold on other farms within 1 year of bund construction and by greater than 50% after 3 years with similar farming practices. The land that could not grow any crop yielded 800 kg/ha of wheat after application of soil conservation measure. On 0.0625 ha of this land a well-grown rice could give yield that fed 7 members of a family for 3 consecutive months. Mr. Suresh was one of the farmers that were the most affected by soil erosion problem. The slope of his farm was more than 20% and the topsoil was totally washed away. What could be seen on the land were subsoil and the soil parent material. Crop could not be totally grown on most parts of the land. The yield, crop, he could harvest was from the homestead and downslope lands. He said that he tried to conserve his soil using some local practices, but due to the steepness of his land the low efficient local practices could not improve his soil. As a result he became pessimist of the soil conservation. Finally, with the help of researchers, he constructed soil bunds, planted stabilizers, elephant grasses and shrubs, Fig 3, and did continuous maintenance. We made continuous participatory monitoring and evaluation and observed the improvement of the soil from time to time. He always praises God and us. We tried to evaluate, assess, the impact 3 years after construction. The color of the soil is changing to black, dark, the organic matter content of the soil is increased, Table 3, which was very low before soil conservation, Table 4, and soil erosion is very much reduced, Fig 4. According to the farmer, soil erosion is reduced by 90%, crop yield increased. He said that yield increased by 50%, the topsoil is building up. The farmer was very much amazed by the build-up of the soil because he said that he was afraid where to bring topsoil from to fill the eroded farm. The farmer also witnessed that his living standard is improved after construction of soil conservation due to yield increment and became optimist. Together with the soil conservation measures, improved wheat variety was also introduced to the watershed by researchers of Vivekananda Agricultural Research Center. As a result of this, the farmers who conserved their soil and planted the rice and wheat got incredible amount of yield. There is no any sign of soil erosion observed on the field. The soil is built up, it became dark, retained moisture well due the construction of the soil conservation measure, Fig 4. Though the farmers grow a number of crops in Jajali area, they obtain very low yield even with application of fertilizers. But after construction of soil conservation structures, crops yields are significantly increased, although the increment differs from farmer to farmer as the management of soil by different farmers is not the same, Table 2. Yield of rice was increased from 750 kg/ha to 1350 kg/ha and from 180 kg/ha to 300 kg/ha on different farms. Lentils was increased from 180 kg/ha to 320 kg/ha, from 70 kg/ha to 110 kg/ha and from 50 kg/ha to 150 kg/ha on different farms. Yield of wheat was increased from 800 kg/ha to 1400 kg/ha and from 300 kg/ha to 500 kg/ha. Maize yield was increased fourfolds, from 400 kg/ha to 850 kg/ha. Conclusion. Soil degradation is the most serious problem and threat to food production, food security, and natural resource conservation in the highlands of Northern Uttarakhand. As most of these lands are sloppy, soil loss due to soil erosion is very high. Removing all the top fertile soils, applied fertilizers, and sown seeds, farmers are remaining with no or very low harvest when cultivating these vulnerable lands without proper management. The study clearly showed that improving the productivity of highlands, which are prone to soil erosion, without soil conservation is impossible. Therefore, construction of soil conservation measures in the degraded highlands and stabilizing with multipurpose plant species is very important to conserve the soil and increase crops yields.